In this demo, we will see how to record and run the traces using Sniper Simulator. Traces are an important tool for debugging the simulator as well as the application. So in order to record traces, we use a file known as record trace inside the main Sniper directory. Now let us see how do we record traces. So for recording traces in our demo application FFT, we first need to make an executable object for that particular application. We do this with the make command, specifying the directory where we want to make it in. Okay, so this has executed the application and created an executable object. Now we run the record trace file inside the Sniper directory. Yes, sorry. So record trace file inside the Sniper directory. We pass it the executable object that we created and the path of the directory where we are creating it in. Okay, so using a single processor, and this would create the trace file. So the trace file is contained inside this pipe called as fft.sift. This contains the entire trace file for the particular application. However, we cannot view it directly. In order to view it, we have to go through the folder called as sift. Inside sift, there is this executable called as sift dump. We have to run this pipe that we created through the sift dump executable. Now let us see how do we do that. From the Sniper directory, we go inside the sift directory and the sift dump executable. We pass it the name of the pipe that we want to run. So the pipe is fft.sift in this case, and we use the less option because this is a huge instruction trace, so it will just keep printing on the screen, and we want it to halt so that we can analyze. So we use the less option. You can also dump this inside a text file and compare it with other simulators for debugging purposes. So we enter. As you can see, this is the instruction trace for the FFT application. You can view as much as you want until you find the right position, and you can debug your application as well as your simulator. In Sniper, it is also possible to record and simultaneously run those traces. Now let us see how do we do that. For that, we will just halt this viewing trace process. Okay, so in order to simultaneously record and view traces, we run the command mknod. Mknod. We create a pipe for our application. We call it sift f51 pipe.sift. Okay, and we create another one with name f50 pipe2.sift. Okay, now we have created the pipe. Now what we will record traces for these two applications. Record trace. We pass these executable pipes that we have created. Pipe, and we run the test application so that the executable is produced. So we have created a pipe and done the executable. We do that for the second application as well, the same process. Okay, so now we have created. Now all we have to do is run these recorded traces. For that, we type the run sniper command. We use it in the default Gainston configuration. We use 2 cores and we supply the input trace file. This file is supplied with the trace flag. This flag lets Sniper know that it has to run a trace file and not the typical application that it runs. And we give the location of this. This is fft pipe.sift, comma fft2. Oh, comma fft2 pipe.sift. We run it. Oops. Okay, so there's a typo. This is traces. Alright, so now you can see the processor is running the traces. It's simulating all the traces here of the two application, and it is done simulating. You can see here that it is using this shift trace driven front end method for running the application, and it is running it in full detailed mode.